to the people who made the big journey from Goulburn. Where are you, Goulburn people? Well done. And also a big journey for the people from Cooma and the Snowy Mountains region. Sorry about the warm weather we're giving you today in Canberra. Oh, please, mobile phones turned off. Can you just double check that they're not on? Just a quick mention about our support group. Membership starts in August, runs for 12 months, good value at $25. We've got application forms here if anyone is not a member of the ACT Parkinson's support group. And we have a Unity Walk coming up on the last Sunday in August. So if you want to be involved in a very public display of Parkinson's people, come along to our Unity Walk or participate in the walk on the 25th of August at Lake Burley Griffin. I'm delighted to welcome you to the inaugural address on the current state of research into Parkinson's disease by Professor Simon Lewis. Parkinson's affects 1 to 2% of the population aged over 65 years and costs the Australian nation more than $6 billion per annum. Here in the ACT, it is estimated that at least 1,000 persons are living with Parkinson's, and this figure is sadly expected to grow as the population ages. We can also expect to see more persons under the age of 40 being diagnosed with the disease. Last year, George Webb, sitting at the front, a member of our management committee, suggested that we introduce an annual address in the hope that a series of such addresses by researchers of national and international repute would help our members gain a better understanding of the current treatments available, their degree of success, and what new treatment pathways are likely to be pursued in the future. Dr. Lewis is Associate Professor in Cognitive Neuroscience at the University of Sydney, Director of the Parkinson's Disease Research Clinic at the Brain and Mind Research Institute, and Head of the New South Wales Movement Disorders Brain Donor Program. Dr. Lewis is also presently heading the first trial to evaluate community-based Parkinson's nurse specialists in Australia. This morning, Dr. Lewis will be taking us through his research team's approach to improving the quality of life for people living with Parkinson's. This work tackles a range of symptoms, including memory loss, sleep disturbance, freezing of gait, and hallucinations, as well as the efforts to provide better services in the community setting. I have very great pleasure now in inviting Dr. Lewis to present the inaugural Parkinson's ACT address. Please give me a very warm welcome.
Thank you so much for that very warm introduction. It was an introduction that a mother would have been proud of. I'm glad that her cheque arrived in time. I'm always humbled when I get an invitation to give a talk like today, and even more so when I see people actually turn up. Especially when people have come from such long distances away. And especially when the fact is, I know when my alarm went off at 5 o'clock this morning and I felt a bit sort of grumpy and a bit tired, that it wasn't that easy for me to leap out of bed and say, yeah, let's do this. And I realised, you know, looking around the room, how much effort most people in this room have made, much more effort than I have made to get here today. And I'm absolutely humbled, and I'm so grateful to the people here for inviting me to come and speak. And also, I think we should acknowledge the work of the committee who've put this together and the local support groups who've come from their distances away. I'm really proud of you guys. Thank you very much. The other acknowledgement I wanted to put up front before I forget is for our hosts today here at the Irish Club in Canberra. My mother's Irish, and I was going to say Dad Wits in Gaelic to say hello to everybody. And but I think it's amazing that when we had to change the venue for today because of hopefully the numbers, we were really, I think, astounded to see the level of generosity from the Irish Club here, who have put all of today's event on at no cost. So thank you to the Irish Club. Okay, so the bottom line is I have a funny accent. I never had an accent before I came to Australia. And if you don't understand what I'm saying, it's probably my accent. The other reason is that I do speak quickly. If you want to interrupt me and stop me, do so. I won't be offended. What I've said to the guys is that I will give a copy of the slides to the organisers, so they'll be able to go through them, and if people want to have copies and then read them at their leisure because they missed things, then that's available. As you can see, the talk is going to be more questions than answered, and it's fair to say that what we're going to do is have me talking for a bit and then really open things up for you. What I always am very careful to do when I give these talks is to try and emphasise to people, I cannot give you advice on your own disease. That's why you have your own specialists, examples like that. But I will be able to speak generally about pretty much all of the questions you have to ask. And if I don't know the answer, I'll try and go away and find it. And if I don't know the answer, I thank you for putting it in my mind so I can learn about these things. Okay, so who is this bastard Parkinson? Well, he was English, and that's enough for me. I'm Welsh, so he was an Englishman, 1817, and he wrote this paper called An Essay on the Shaking Palsy. And it's interesting because he was actually a GP who had observed cases walking around his area in Hoxton in London, and he went up to see a few of these cases and he described them in this paper. In actual fact, he was a really good guy and did more actually for political activism. He got people involved in getting the vote for people like women and getting the vote for people and getting unions started for the poorer people. And his main passion actually was fossils. So he actually has more fossils named after him than diseases. Those curly ones, the ammonites, are what he's most famous for. And of course, he wrote this one medical paper for which he has become immortalised now, because about 50 years after this paper was written, a French neurologist started seeing cases of Parkinson's disease. And in fairness to him, he said, look, I've read about this stuff before. This is what we'll call Parkinson's disease, and that name is now stuck. The Americans are trying to change it to Parkinson disease, rather than Parkinson's disease. They've always had trouble with spelling. And apostrophes are not necessarily Australia's thing either, I have to say. I go around this King's Cross, Potts Point. What happened to all the apostrophes? Did the possums steal the apostrophes? What's going on? In terms of what Parkinson's is, it is a common neurodegenerative disease, so second only to Alzheimer's. And by a neurodegenerative disease, it's like a rusting of the brain, so cells in the brain are dying. And specific parts die faster than other bits, and I'll tell you why that's important a little bit later. We mentioned how common it is. It's one of those things that affects people who are in their retirement years, and generally comes on in your 50s or your 60s, but of course it doesn't spare people under the age of 40, and about 5% of cases are under the age of 40, and we guesstimate around 80,000 cases around Australia. It doesn't matter where you are in the world, the same frequency of Parkinson's is in place. It is fair to say that there are slightly more men than women, and we don't know why that is. I think it's just because men complain more, especially when they want to build model railways when they get to retirement age and the tremor gets to them. In terms of the causes, we don't know the cause. We know there are genetic factors, and we know there are environmental factors, but we don't have a smoking gun that says this is the cause. However, I thought I'd take you through these because often they're very common questions when I come to support groups. The genetics of Parkinson's is complicated, but there are a number of genes, about 12 genes have been reported that can give a Parkinson's disease presentation. But these diseases are very rare, and they account for less than 2% of all the people in this room who've got Parkinson's around the world, okay? Most of these cases look pretty different from the Parkinson's that we see, and they often have a very strong family history, 5 or 6 members of the family who've got Parkinson's, and often a very young onset. And people say to me, oh, you know, what's young? In these cases, under 30. So already you start thinking, oh gosh, well that's a bit different. So most people who have a genetic cause of Parkinson's are under the age of 30. Having said all of that, we do know the genes are important, because some of the genes that can occur do look exactly like Parkinson's disease and come on in later life, in people who are in their 50s, 60s. In fact, I've seen one of these cases in their 90s. And so it can look exactly the same. And then in terms of the other influence of the genes, we know that at large there's about 1 in 1,000 people who've got Parkinson's. So if we went out now and tried to find 1,000 people, actually we probably wouldn't find a single Parkinson's case because you're all in here. But if we went out and found 1,000 people at random, about 1 of them would have Parkinson's. However, if we went around this room and said, right, okay, hands up who's got Parkinson's? Hands up. None of you got Parkinson's? Christ, this is a good support group. How many of you have Parkinson's? Okay. How many of you with Parkinson's have got a family history? Anybody with Parkinson's? So you can see the numbers are a bit too high for 1 in 1,000. It's about 1 in 10. So the odds change. So there's something about the genes that puts you more at risk. So you can blame your parents for everything. It's brilliant, isn't it? Okay. In terms of the environment, there are a number of things that have been shown to increase your risk of developing Parkinson's. Heavy exposure to pesticides is one of the ones that people commonly talk about. And by heavy, we mean a working life exposed to multiple pesticides. And people often will say to me, well, you know, that's what happens when we live in the country and there are higher rates of Parkinson's living in the country. The truth is, when I do outreach clinics in Dubbo. Does anyone know Dubbo? It's a beautiful landscaped area, harbour views, the marina is fantastic. When I do my clinics in Dubbo, and everybody says to me, Doc, you know, it's because I'm a farmer, isn't it? I've got Parkinson's because of the pesticides. And I say to them, look, what other job is there in Dubbo unless you work in the zoo? You are a farmer. So there's a bit of a skew living in the country. So I don't think the pesticides can be too much to blame. The other thing about these increased risks is what we're talking about is something like a tripling of your risk, okay? Which means you go from 1 in 1,000 to maybe 3 in 1,000. Which, if you think about it, isn't that much of a risk, and it certainly isn't the cause of most of the Parkinson's we see in this room today. Similarly, we know head injury, so in significant head injury enough to make you lose consciousness can put your risk of developing Parkinson's up. But again, lots of people have head injuries and they don't necessarily develop Parkinson's disease. And then interestingly, there are a few things that reduce your risk of getting Parkinson's disease. Now, do not write these down. Smoking reduces your risk of getting Parkinson's disease, okay? Now, we used to say that was because you died of cancer first, but that isn't the case. There is something about cigarette smoke that protects you, but again, you're only talking about a small, so you go down from 1 in 1,000 to maybe half in 1,000 or 1 in 2,000 chance. So hands up who's got Parkinson's again. How many of you have never smoked, never had a puff in your life? So the bottom line is that it hasn't protected you, okay? Whatever you do, don't start smoking now, you'll burn the house down, okay? You'll tremor, you'll drop a match, it'll be terrible. Caffeine, at this point I should have a glass of Coke lying around. So caffeine, so coffee, tea, Coke, it reduces your risk. And the reason I need it is because in medicine they say you die in your specialty. So bowel surgeons die of bowel cancer. So I'm retraining as a sex therapist. What a way to go. We've heard from the introduction how common and how expensive this disease is. It's about $8 billion per annum in Australia. And it's not just the financial cost, of course, it's the healthy life years that we lose in Parkinson's. And also, of course, society, because in actual fact this is going to cost us. It's going to cost us all. You know, if you look at what's been going on in Parliament, and geez, we're right on the doorstep of Parliament here. Don't they go on? They've been talking about the aged care health provision, and you know, over the next 20 years we've got this ageing population. And this is a graph I've titled Fortune Telling. And this is about the increasing cases of Parkinson's disease we are expecting in the next 20 years. And it's an 80% increase because we've got an ageing population. And the reason I say it's fortune telling is if it costs us 8 billion today, it's going to cost us a fortune in 20 years' time. And if I could just convince the government of that, we'd be able to spend a bit more money now and save a lot more money later. It's not very often that I put the UK up as a good example of anything. Let's be fair. Oh, thank you, by the way, for putting on some weather to make me feel like I was back in Wales. There was no need. It's okay. I'm not missing it. In terms of the UK, they did this thing a number of years ago now, I think it was about 2005, where they said these are the guidelines for treating Parkinson's disease. And what they did, right in the middle, in that green box right in the middle, was they put this thing here. A continuing point of contact, including home visits when appropriate, which may be provided by a PD nurse specialist. So the UK got onto this idea, and they've had Parkinson's nurse specialists now for over 25 years. There are, you know, a big community of Parkinson's disease nurses. And of course, we're just about joining the party now.
A new study into Parkinson's disease has shown big benefits for patients cared for by specialist nurses. Researchers say the 2-year trial at Shoalhaven in New South Wales saw patients' symptoms decrease, and the health of their carers also improved.
Australia is facing a crisis. We've got an ageing population, and with Parkinson's it's predicted that over the next 20 years there'll be an 80% increase in the number of cases.
In the Shoalhaven study, carers who were taught to prepare and administer the drug infusions reported their own health improved as well. Doctors see the specialist nurse scheme as a way of reducing the Parkinson's burden, not just on sufferers but on the health system.
But certainly we know that if we can defer people entering a nursing home, there'll be an enormous cost saving.
So that was a news report based on our study in the Shoalhaven region of New South Wales, where effectively what we did was to convince the government to fund a pilot study where we were able to put a nurse into the community who would serve the patients living in that area. And this is a little bit about what they do.
Aurelia Pereira was appointed as Australia's first neurological nurse educator, providing support to dozens of people living with Parkinson's.
To assess any of their symptoms, treat any symptoms that were identified, to also look for any risk assessments and early on, so they don't end up in hospital prematurely or residential care facility. They have to leave work so they don't have an income. On the health system, you know, if they go into hospitals, in acute care hospitals because of falls, for example, or constipation, that costs the health system.
So the Shoalhaven project is still sort of going on. We still have Marilia down there. But more importantly, we've been able to use that data and use that model to leverage things. And I'm really proud and pleased that a couple of years ago now, I think it was, with the help of people in this room, where are you, Mr. Smith, who went and lobbied the local local ACT government or assembly. You now have your own Parkinson's nurse serving the ACT, Sally Ann Wherry, who I don't think can be with us this morning. But how many people have had any interaction with Sally Ann? Isn't she amazing? Yes. Yes, absolutely. The worst part is when I talk to government, they all say it's a brilliant idea, it's a no-brainer, we should do this. Can I get the bastards to pay for it? No. And I love this example. This is from the Queensland state election. This is a lady called Anna Bligh, who in her manifesto said that if she'd got in, she would have funded 4 of these nurses. Unfortunately, I don't think she had that many votes, which didn't mean that it didn't get off the ground. And interestingly, of course, I don't have a political bent either way. It doesn't matter to me. Whoever pays is great. But when we spoke to the Liberals who got in and said, look, are you going to match this? Stony silence. So it's a really big, big problem that we have to come up with some solutions for. The other thing that people ask me about with solutions is, well, what about the cure, Doc? Where's my cure? Currently, we have no cure for Parkinson's disease. Please beware anybody who tells you they've got a cure, they've read about a cure, they've seen a cure, they've heard about a cure. I get emails every day from people telling me that they've heard about stem cells or gene therapy or rhubarb baths or vaccination or electrical stimulation of the testicles. None of these things have any basis of truth. The fact... You may enjoy these things, but they're not cures. None of our governments are so stupid as to overlook the fact that actually it costs a lot of money in terms of treating Parkinson's in this country. And if you could buy a cure for $15,000, which is funnily enough just about where most of these places like China and India pitch their stem cell therapies, not enough money to think, well, that's cheap and it won't work. Not too much money to think, well, I'll never be able to afford that. Just about enough money to clean out your savings. Please do not go ahead and do this. Okay? If there was a cure, trust me, the government would buy it. The other question that gets asked is about disease slowing, and I wanted to just labour something because you sometimes get media hype. And so there is some data about neuroprotection, which is slowing the disease, but it's highly controversial. And it really relates to this medication called rasagiline. And I want to just, at this point, state I have a conflict of interest. I sit on the board for Lundbeck, who supply this drug around Australia. But effectively what I wanted to do is to clarify people, just in case you think that this is a drug that can cure the disease or it will stop it in its tracks. It does not do that. It is a good treatment for treating symptoms. In the early parts of the disease, if it's your first treatment, it's a very helpful treatment. It's a good treatment in the later part of your disease if you're suffering with off periods, switching off. We've got good data on all of those things. And there is some mixed data that it might slow the disease. But it's not stopping the disease in its tracks, and the data has been really controversial, and people don't necessarily believe everything that's been published about it. But this is the news that...
A drug that could change the lives of thousands of Australians will soon be available at a fraction of its current price. The federal government is putting the medicine on the PBS list. Welcome news for those who suffer from Parkinson's disease.
For Ronnie Hall, doing the little things like walking are a big achievement.
It's hard to get down and do certain jobs you used to be able to take for granted, you know, cutting or gardening, and it's hard to do handyman work at home.
Ronnie has Parkinson's disease but says it could be worse, like the symptoms suffered by this patient. It doesn't have to be so bad anymore. There's a new drug called Azilect or rasagiline that's just been listed on the pharmaceutical benefit scheme.
What we're talking about here is a drug that can be used in patients who are newly diagnosed, right through all the stages of Parkinson's to the very, very advanced cases of Parkinson's disease.
It's taken once a day and can have impressive results.
So the bottom line is that the editor was really good, and what they didn't show much of was the next clip, which I'm going to show you, and I'll play it nice and loud.
It's not a miracle cure for Parkinson's. It's not a miracle cure for Parkinson's, but there are lots of patients out there today who should be celebrating that they'll have an extra thing that we can help to use to treat their symptoms.
And it is useful that we're getting new treatments, okay? And then just last month there's a new treatment in Australia which is now licensed on the PBS called rotigotine, and that's a patch that you can put on the skin, and it's again another useful treatment. But none of these things are cures, none of them stop the disease in their tracks, okay? So as I say, no cures, be careful about people trying to get your money off you. Obviously remember we do have some other therapies, the advanced therapies like apomorphine, duodopa, deep brain stimulation. All of these advanced therapies are very useful. They all do about the same amount of good for reducing the amount of time you spend with off, but it comes down to individuals, which case, and discussing it with your specialist. The bigger question in some ways is why don't we have a cure for Parkinson's? We've known about it since 1817, and the answer is like this. Parkinson's is like a box of chocolates, okay? So in a box of chocolates you've got some square chocolates there, and you've got some round chocolates there, and what I always like to think about is that some of you are soft centres, some of you are tough nuts, okay? But the bottom line is, if you've ever been to a support group meeting, you'll realise that you are all very different. It's a bit like that Monty Python, you know, we're all different, I'm not. Yes, we are. A lot of the patients that we see in the clinics look, you know, as though they might fit patterns, but everybody's got individual problems, which is telling us about the disease. it makes it complicated because we've got all of these different pathologies going on in the brain giving different symptoms. And one of the things that I'm involved in, as you heard, is trying to find out what those differences are in the brain and what therefore we might be able to do in the future to think about treating symptoms.
It's one of the cruelest of diseases and affects 80,000 Australians, but there is hope on the horizon for those with Parkinson's disease.
The project is funded by Parkinson's New South Wales, along with a new brain bank, where patients participate in live studies and then donate their brains for global research.
It's the first time we'll be able to actually study people through the course of their disease and then study their brains. And this is really exciting because we hope it'll give us new information that will unlock the secrets of Parkinson's disease.
So this is the brain donor program. It's unique in the world because we are, as we say, going out and seeing patients regularly all the way through their disease, and then those patients volunteer and they actually donate their brain. You're only allowed to donate after you've died, okay, not before, all right? The bottom line is we are very proud to partner with the Sydney Brain Bank, who've been doing this program in isolation for about 15 years now. And what we are able to do is basically, if there are research teams anywhere in the world, America, Europe, wherever, if they've got a bright idea and they want to get hold of the tissue and they want to get hold of the clinical data that we've collected on these patients, they can have it. Because the bottom line is I realise that I'm not smart enough to cure Parkinson's disease, but I'm not proud enough to... I have no pride at all when it comes to helping somebody find a cure for Parkinson's. So the bottom line is we're there to try and help that process. And the program covers not only Parkinson's, but people who've got Parkinson's plus, so PSP, MSA, all those other conditions, and also people who don't have disease in their brain at all, because we need to compare the tissue to healthy controlled circuits, as we say. So what our clinic does is it tries to focus on finding an improvement for quality of life, and as I say, we'll try and help anybody find a cure if we can. We generally see people every couple of years and we look at the whole of their disease, so we're looking at the physical and the non-physical aspects of the Parkinson's disease. And ideally what we're really doing then is filtering them into different studies that we have going on, looking for better treatments, better options and better understanding. And what we're trying to do is find the right chocolate in the right box, as it were. In terms of advanced disease in Parkinson's, we've got some major challenges. We know, for example, that the rate of nursing home admission is 10 times greater in Parkinson's than in the ageing population. And the three things that put you into a nursing home with Parkinson's above and beyond any other are dementia, hallucinations, and falls. So a lot of my research has been targeting these problems. For those of you who don't know it, this is what freezing of gait looks like. Not a frozen gait, but this is it. This guy comes up and he sticks to the ground, and of course as soon as he does that he's very unsteady and he's likely to fall. How many freezers have we got in the audience? I was going to say, there'll be a lot. At least half of the patients with Parkinson's disease will get freezing, and so we don't know what causes freezing, but what I decided to do a couple of years ago was try and understand what's going on in the brain when patients freeze. And the way that we've approached that is to try and trick the brain, and this is a bit of video from Catalyst a couple of years ago. Hi Brendan, we want to see you do a little bit more walking for us now.
Okay.
Okay, off you go.
Participants walk by using a pair of foot sensors while watching a graphic of a corridor adapted from a computer game.
We'll freeze there. So what we're able to do is to try and convince the brain that you're walking along, and is this virtual environment. And basically what happens is just the same as when you're walking along in the real world, you start freezing in the virtual world. And this is
There's renewed hope for all those with Parkinson's disease. More than 40,000 patients suffer from a debilitating symptom which literally stops them in their tracks, unable to move. Now doctors are using virtual reality to help patients move forward.
When John Marshall's Parkinson's medication wears off, this is what happens. He's stuck, unable to walk properly, a condition called freezing of gait. Until now, there's been little that doctors can do. Pills or surgery aren't very effective.
Patients feel as though their feet are being glued to the floor suddenly. They don't know when it's going to happen. It's very unpredictable.
To unlock what's going on in the brains of patients who freeze, doctors at Sydney's Brain and Mind Research Institute have turned to virtual reality. patients press a foot pedal to move through the virtual world. Amazingly, they found Parkinson's patients were just as likely to freeze in the virtual world as they were in the real one.
Effectively, what we see with our experiments is it doesn't matter if you're walking in the real world or lying on your back using foot pedals, you can still provoke the same phenomenon.
Doctors discovered when patients freeze, the part of the brain that controls movement goes cold, while other parts of the brain surge to try and move the feet.
So it's a very, very interesting finding because it allows us to say, well, is there something we can tap into there that might work as a treatment?
So this is the big challenge for us, is to say, okay, now we understand a bit more about it, what can we do to try and help treat it? And this is...
So what have you done to my head?
A little bit.
We hooked you up with a lot of different
right.
electrodes. If you look at back there, you actually can see your brain wave.
So this is quite literally reading my mind.
Definitely.
So that's Hung Nguyen, who's from the University of Technology in Sydney, and he's really smart, and I like him a lot, because he came up to me when he saw the stuff with the freezing of gait and said, I've got this neat trick, I can read brain waves in real time. And what he's done, and this is a catalyst show that Hung did a couple of years ago, he actually can get people to drive a wheelchair just using their thought, and they can steer it. What we've done with Hung is get this same technology on people with freezing, and we've published a paper now showing that 5 seconds before somebody sticks to the ground, Hung can detect the change in the brain waves before they freeze. So one of the big challenges I'm now trying to take on is trying to develop a technology whereby we can bring that out into the clinics so that people can actually have an early warning system. You know, something that will say to you, you know, be careful, you're about to freeze, get safe, get steady, get stable, or stop. Or, you know, something to focus, you know, lift your knee, lift your knees, you're going to freeze, or some catchy slogan perhaps. But the idea of taking research forward now is something that might become an intervention, a treatment. And the other thing we're going to do in terms of treatment is kindly being funded by Michael J. Fox Foundation. And this really follows on from some of the findings we had with that virtual reality work. And what we found is that the freezing that people experience is related to how quickly they can think. Okay? And that's because actually the brain circuits are probably going through the same pathways. So what we're now doing is a study in Sydney where we're able to bring people in for 2 afternoons a week for a 7-week program, where we're actually training them to think faster, okay? So they can process more information, and our hope is that that will reduce their freezing. So we're going to thaw the brain and try and defrost their feet. That's our plan. And we will be recruiting for that now. And it's interesting because this thing about cognitive function, this thinking and memory ability, is something that's obviously very dear to my heart, going back to some of the work I did in Cambridge before I came to Australia. Memory problems in Parkinson's are huge. People don't like me talking about it, but I'm going to. At the time that patients are diagnosed, at least half of them have got memory problems. By the time you go around looking at people in this room, about 15 to 20% will have proper dementia with Parkinson's. And after 20 years worth of disease, there's, you know, a very high risk that you're going to get these significant memory problems. And we don't really have any good treatments that will help. So what my team have done, mainly led by Sharon Naismith, who's in this photograph here, she's the blonde, is to develop a specialised memory training program for Parkinson's disease. And again, this is a 7-week program, 2 afternoons a week, where we tell people about strategies, how to improve your memory. So for example, if I said to you now, think about your shopping list. It's enormous. You can't, you know, I mean, it's tricky. If I said to you, think about your shopping list, but I want you to think about the dairy products you're going to need to buy. Suddenly you go, okay, well dairy, I'm going to need this, this, this and this. And I say, okay, think about the cereals you're going to need to buy. Okay, well cereals, this, 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 this. Think about, you know, meat. Think about, and breaking it down gives you a strategy to give your brain a chance to remember your shopping list. And the team, you know, with Sharon leading it, has done an incredible job here. And what we've just published is the world's very first study that uses memory training to improve memory in Parkinson's disease. So no tablets, just working the brain and trying to get you to remember better. Now, I'm not saying that's a cure for dementia, but if you're smarter for longer, the chances are you will stave off those problems and avoid going into a nursing home. My big challenge now is, having come up with a memory training program that works, is convincing somebody to pay for it. Because the bottom line is, it's really annoying to me. I write grants all the time. Hello mate, how are you? I just saw you. How are you? The bottom line is, I write grants all the time telling the government, I'm going to try and do this to solve this problem, and if it does, I can stop people going to a nursing home. Can I get the buggers to pay for it? Is the heart of it. And really we rely on, grant funding to get this, and this work was funded by Parkinson's New South Wales. And frankly, if you've got any friends who are millionaires, multimillionaires, who want to spend money in Parkinson's, please send them my way, and we'll tell them how to spend their money well. What else have we done?
Your phone could be the best hope against Parkinson's disease. A new Australian program is helping in the early detection of the disorder.
The Brain and Mind Institute...
Oops, so sorry, I hit the wrong button. My bad. As I was trying to turn up the volume.
Your phone could be the best hope against Parkinson's disease. A new Australian program is helping in the early detection of the disorder.
The Brain and Mind Institute and Parkinson's New South Wales have developed the Dash to the Info Line program.
It might mean that if we could recognise these red flags earlier, we might be able to step in with a therapeutic window if we can slow the disease in the future with agents that can target the progression.
Having experts on the phone eases the shame.
And the sort of things that people don't want to talk about because of, you think about men who've been head of the house, breadwinner, and the idea that that's going to change and they're going to become, in their mind, a crumbling wreck who's a burden to their family is something they just can't face.
So this is the Dash to the Info Line program, which was funded by the Commonwealth Government, again another grant, in which we produced this booklet, Dash to the Info Line, the purple booklet. Has anyone seen this? A few people. So the bottom line is, this is available. I'm sure that if you haven't got any copies in Parkinson's ACT, Parkinson's New South Wales will give you them. And if you haven't, or if you have access to a computer, you can actually download this as a PDF online. And basically, the DASH program was looking at quality of life and looking at those things that increase your risk of memory problems in Parkinson's. And when we look at that, what we found was that there are things like depression, anxiety, sleep, and hallucinations. And of course, that spells out DASH. And what we did, we produced this booklet with some insights into looking out for those problems and what to do with them if you recognise those problems. So I think there were 20,000 booklets produced, and they went completely in, I think, less than a month. We lost 20,000 booklets, and we had to have a reprint another 5,000 booklets and some bookmarks. And subsequent to that, our Chinese support group, Chinatown support group in Sydney, have actually had the booklet translated into Chinese, and I know a number of other ethnic groups are now looking at trying to get it translated for their people living around Sydney and Australia. So just touching on things like depression and anxiety, we know it's common. At least a third of patients will get depression and anxiety, and it is not simply a reaction to your physical disability. And we know that because there are other diseases that have got far more physical disability that don't have anything like the rates of depression that you see in Parkinson's. We know that the correlation with disease severity is pretty poor between depression and anxiety. And most importantly, in some ways, we know that your depression and anxiety can actually predate your Parkinson's. So people developing depression and anxiety in their late 50s or early 60s, and then 5 years later going on to get Parkinson's disease, is something that we're becoming much more tuned into as a possible risk factor for getting Parkinson's later on. There's a very different profile to depression and anxiety in Parkinson's disease. It is different from the standard guilt and depression that you see in depression in other populations. It is much more problems with concentration and feeling that you can't get on and do things, and it just, frankly, is frustrating. I mentioned earlier that we lose different parts of the brain in Parkinson's with rusting, and obviously the major hit is in the dopamine system, and that's what we think about when we think about the physical symptoms of Parkinson's. But the chemicals underlying depression, so serotonin, are also lost in Parkinson's. Now I ask you, you're happy to take dopamine to replace chemical for your physical symptoms. I would urge you, if your doctors are asking, to look at the medications to replace the serotonin in your system as well. If your mood is down, taking tablets for this is not a bad option. You're happy to take tablets for your movement. I think you should be happy to take them for your mood. And of course, there are non-drug approaches, so counselling, getting some help, being able to talk about it, and engaging not only you, but your partner and your family, because it gets to them too, I promise you. The other letters we have in the DASH booklet, we've got depression, anxiety, DA, is sleep. And sleep problems are huge in Parkinson's disease. And we don't quite understand what's going on in the brain that cause the problems of sleep in Parkinson's disease. But again, we know that they can occur before the physical symptoms happen in Parkinson's. Now, it's said that sleep-wake disturbance affects about 60% of patients. Hands up, all patients in the room? We got Parkinson's? Okay. If you have no problems with your sleep, and you are brilliant, you may put your hands down. If you're Parkinson's and you have got terrible sleep, you're either falling asleep during the day, you can't get to sleep at night, can't stay asleep at night, yeah, you're out there and I know you. The bottom line is that we have probably 3 major problems. Leaving aside the bladder and having to get up for the bathroom in the night, getting to sleep, staying asleep, getting back to sleep, insomnia is huge, excessive daytime somnolence, and I have to say congratulations, most people have stayed awake so far. We've only got another 2 hours to go, so don't worry. And then my favourite is this thing, REM sleep behaviour disorder. How many people, hands up who know what REM sleep behaviour disorder is? Hands up. Beautiful, okay. Look at this video. This is a guy who is asleep, okay? Oh, it's a bit poor, isn't it? Never mind. Here he is asleep. Now imagine lying next to him. Hands up how many of you have experienced this? Yeah. So you didn't know what it was called, but you bloody well know what it is, huh? So this is REM sleep behaviour disorder. So this person is asleep, and in their sleep they are able to act out their dreams. And of course, it can be very violent. I don't know about your dreams. In my dreams, Kylie Minogue doesn't come knocking. Simon, are you free for dinner? No. Kylie's boyfriend, who always has an axe, comes knocking, comes crashing through the door, and of course I run. This is why REM sleep behaviour disorder happens. This is a cartoon of the brain, and that thing there, which is black, is called the substantia nigra. The substantia nigra is a very flash and Latin way of saying black stuff. As doctors, we have to make it sound clever. And that's the bit where the dopamine is in highest concentration. And that's the bit that you lose with Parkinson's disease. But the disease itself starts lower down in the brain. And if you can see that bit that's there in red, down there, that's where it starts. Okay? Now the truth is, during sleep, your brain is very active during this stage of sleep. Your brain almost looks like it's awake. But there is a mechanism in the brain that stops the dreams from getting out. There is a gate that stops them. But in Parkinson's disease, that gate is broken, and the dreams are allowed to come flooding out. And what's interesting about that is that that symptom can predate the Parkinson's disease by years, 60 years in some cases. So this is an area that I'm very interested in, because what I'd really like to do in terms of saying, look, how do we go about a cure, is not trying to cure people who are in wheelchairs. I'd like to try, it's going to be much easier for us to cure people before they get their Parkinson's physical symptoms. And these people presenting with these sleep disturbances represent a group that we might be able to target very early, before they get any of the physical symptoms of Parkinson's. In terms of sleep, it's very important, not only because of your physical symptoms, and everybody knows that if you have a bad night's sleep, your physical symptoms are worse the next day, but also because it's very important for your memory. Sleep is there helping you consolidate what you've done during the day and learn new things. And if it's disturbed, your memory is affected, and therefore, if your sleep is bad, you're more likely to be someone who goes on to get memory problems. In terms of managing sleep problems, any New Zealanders in the audience? Look, I'm Welsh. I have the same jokes. This is not a sleep management thing, okay? Counting sheep doesn't generally work. We need to look at things like your physical symptoms, whether your tablets have got the right doses, so that you can go to sleep and not get switched off, and then not be able to get comfortable and go to sleep. REM, sleep behaviour disorder, where you're punching in your sleep, has got some specific tablets that can help with that symptom. You can discuss that with your specialist. And you also need to look at these timings, because vivid dreams, which is a very common symptom, may be related to the timing of your dose and what time you're taking your tablets. Other important strategies: getting some massage, getting some exercise during the day, stretching those muscles before you go to bed, and also some relaxation techniques. So listening to tapes of music or listening to things that relax you and regulate your breathing can help you get to sleep. Having regular sleep times, going to bed at regular times, waking up at regular times, and not napping through the whole day. So we've got some data at the moment that shows that the amount of napping in Parkinson's patients is 225% greater than it is in age-matched population. So the fact of the matter is, we must limit the naps. So ladies, gentlemen, sharpen your elbows when your partner is asleep, no more than 30 minutes during the day. Keep them awake. And I want you to avoid hot baths and vigorous exercise before you go to bed. And people always look at me and go, oh, vigorous exercise in bed, doctor. Yes, okay. If it wears you out and you fall asleep, that's fine. But no vigorous exercise. And caffeine. Many people can't take caffeine in the afternoon because they can't sleep. And the bottom line is, caffeine is a chemical that works in your brain to keep you awake. So you must try and avoid caffeine late in the night. My grandmother told me that if you couldn't sleep, you should have a milky drink before you go to bed. I've never seen any research to say my grandmother is wrong, so I'm giving you this as gospel. Take a milky drink. The other thing I would say is, if you cannot get comfortable, you cannot get to sleep, get up, because you're doing yourself no favours. Get up, have a stretch. But you must not go into a very stimulating environment. So you mustn't do what I do. Okay? Doctors say, doctor do. Different things. Don't get up and go, I can't sleep now. I'm going to check my emails and go on the internet for the next 2 hours, and then you're not able to get to sleep. That's okay for me, because I'm supposed to be saving Parkinson's disease patients, okay? If I end up spending all night awake and doing this stuff, that's fine. Not good for you. You need your rest, okay? So the bottom line is, don't get too stimulated. If you're going to get up, keep the lights low, don't put the television on, go somewhere that you can feel a bit more comfortable and you can relax. In the DASH project, we've talked about depression, anxiety, and sleep, and the final thing is H, hallucinations. And hallucinations are really common in Parkinson's. 7 out of 10 patients by 10 years are getting some degree of hallucinations. And they come in different forms, and I'll talk about those a little bit later on. We know there are a number of risk factors for developing hallucinations. So we know the longer you've had it, the more tablets you're on, what sort of Parkinson's you have. So more tremor, usually less hallucinations, less tremor, usually more. And of course, if they come out of the blue, it's often related to something that's changed, either a new tablet, which may or may not be a Parkinson's tablet, or a new illness. Constipation is a really good thing that triggers off hallucinations, believe it or not. In terms of the spectrum of psychosis, I mentioned this earlier, but vivid dreams are very strongly related, and that REM sleep behaviour disorder is very strongly related to the development of hallucinations, and there are some clever reasons why that might be. The next thing is daytime illusions and misperceptions. And these can start very subtly, and we can all complain about these, but that sensation, there's something just lurking at the corner of your eye, and you kind of, what was that? Or something just passing you by. Anyone in the room had any of those? Yeah, absolutely. The other thing that we get is illusions or misperceptions, and you can give this to anybody, okay? So if you're sitting there and you don't have Parkinson's, bear this in mind. The bottom line is, if you go out and you watch a horror movie, okay, scary, Freddy, Nightmare Elm Street, whatever, Frankenstein, and you come home and you don't put the lights on, suddenly every shadow becomes a murderer. Okay? So we can all do that, but in these patients what we're talking about is sitting there and this lamp, this microphone stand, suddenly you think, well, what's that? Is it a person, or what's that out to get me? And they misperceive an object that's real. Okay? The next step along this spectrum is that instead of misperceiving something that's really there and thinking it's something that it isn't, like a person, is that actually nothing there, and you suddenly start seeing things that aren't there at all. Usually animals or people. So little black cats seem to be very popular in Australia, spiders seem to be very popular in Australia, and people, usually friendly people that you've known or loved, possibly lost. I had a lady back in the UK who told me that she used to wake up every morning with her husband, and she said that was queer because he'd been dead for 4 years. The bottom line is, she said it was the most quality time they ever had because he didn't speak. And when she wanted to get rid of him, she'd just reach out and he'd be gone. And she said it was quite a nice thing to have. And that's probably true, but unfortunately it's really the harbinger for this end of the spectrum, where people are very unwell with psychosis, where they see things that are very threatening to them. So for example, if you wake up and you're in Belconnen and there's a Roman centurion at the end of your bed, most people who don't have Parkinson's, with better memory problem or hallucinations, will look at that and go, the Legion didn't make it as far as Belconnen, mate. You're not real. But unfortunately, at this end of the spectrum, you start looking at that Roman centurion and you think to yourself, there's only one of him, and he's only got a sword, and I reckon I could take him. And at that point, you slowly reach for your walking stick and start attacking the Roman centurion, at which point your wife comes rushing into the room because you're now smashing the room up. And she says, darling, what are you doing? At which point you look at her and say, why, darling, I'm fighting with the Roman legion here? Can't you see that? And she says, no, there's nobody here, it's okay. And suddenly she goes from being the closest person he's ever known to being a conspirator who's in it with the Roman legion. And he turns on her. The next thing she does, of course, is says, darling, it's okay. Here, take your tablets, you're not well. And now she's a poisoner and a conspirator. And that situation doesn't go well. And what ends up is he ends up in a nursing home. So this is why it's a very bad symptom to have. We don't quite understand what causes the hallucinations in Parkinson's, but we know the pathology in the brain is contributing. And we also know some other things. We know that people have got reduced visual perception. Not only are the eyesight poor, because there are changes in the eye in Parkinson's, but the bit of the brain that works stuff out is damaged. It's getting shrunken, their cells are dying in it. And what we also know is that you're not able to focus your attention properly on what you need to sort out. If you're given a situation that you have to decide between things, that's not good in Parkinson's with advanced disease. And I looked at all of these things a couple of years ago and said, well, look, maybe this could be used to explain what's going on with Parkinson's hallucinations, and came up with a hypothesis, which we published, trying to explain what causes hallucinations in Parkinson's disease. And the great thing is this is published in a high-flying neuroscience journal. But what I'm going to do now is make you all neuroscientists, and so you can all understand what's happening in the brain with hallucinations. Are you ready? Cool! This will go well. All right. So, at the top of the screen, it's cut off a bit, but what do you see? Hose pipe. But we live in Australia. What else is coiled up in gardens? Snakes! Snakes, snakes. Stay calm, stay calm, stay calm, stay calm, stay calm. It's okay. And what I've told you already is that we've got impairments in processing visual information in Parkinson's disease. So we've got this situation where it could be a hose pipe, it could be a snake. But it's okay because the brain will usually work that out for us. It's got a series of different pathways, networks that will do that. So the bottom line is, the first network is called the ventral attention network, and the ventral attention network is what you all just used. That music starts, you think shark. Who didn't think shark? I mean, that music says shark to everybody and anybody. You basically, this network in your brain is there to protect you from threat, okay? Any threat, this thing is twitched. It's there, primeval days, saber-toothed tigers, people in the media who shouldn't be commenting on anything, all those people you should be attacking or running away from, you have this network in the brain. And there's another network that helps you to stay alive. Who was that? Frank Ifield, Australian icon, of course. And this is a different network in the brain called the default mode network. And the default mode network is very important because it's the network that you've all been using during the talk I've been giving. It is the network that you are using when your mind is wandering off and thinking, what time is this guy going to finish? And what else am I going to do today? When am I going to pick the kids up? What am I going to do with that? How am I going to get home? Do I have to fit that in? You've all been using it, and it's a wonderful network because it's where you store stuff. The trouble is, it's where you store memories as well. And it may well be that those memories are helpful. So for example, you may think to yourself, oh, I'm in the garden. I remember putting my hose in that corner of the garden. Therefore, I've worked it out. It's not a snake, it's a garden hose. I've remembered that. However, if your default mode network decides to go popping something into your brain like, you live in Australia, snakes live in Australia, snakes live in gardens in Australia, that is a snake. Your ventral attention network, which says, snake, and is really panicking about everything, suddenly gets a friend that agrees with it. Okay? And then you rely on a third network. So that was Bucks Fizz from the Eurovision Song Contest, for those of you who are wondering. And effectively, this is the third network in the brain that deals with attention. This is called the dorsal attention network. And normally what happens in the brain, in the suggestion, is that you get this problem. You know, is it a hose pipe? Is it a snake? The ventral attention network thinks it's a snake. The memory system is thinking, well, I don't know, I can't remember hose pipes, I do remember snakes. And your brain will engage the dorsal attention network. The trouble is, to do that, it has to go through the basal ganglia, and the basal ganglia are the part of the brain that rely on dopamine to work properly. And of course, Parkinson's patients have got no dopamine. So with our normal system, the dorsal attention network would kick in, and it would go, no problem, that is a garden hose, got it sorted, no problem. But if that system doesn't kick in, suddenly you're left relying on the other two systems, and instead of seeing a garden hose, you'll start seeing a snake. Okay? So now you understand hallucinations in Parkinson's like a neuroscientist.
Scientists at Sydney's Brain and Mind Research Institute say that hallucinations can be caused by medications taken to treat the physical symptoms, and the part of the brain that governs reason, shown here in blue, not working properly. In this new test, patients are asked whether they're seeing a single or secret image. Those with hallucinations will see images that are not there.
Well, what's very exciting is they can actually perform that task while they're lying in the scanner, and we can see which parts of the brain are failing.
So this is the next step. What we did was I came up with the idea of what causes hallucinations, but then I thought to myself, well, that's kind of cute, but I'd really like to see what's going on in the brain. A little bit like the virtual reality stuff we saw for the freezing of gait. And so I came up with a new test, which we call the bistable percept paradigm. And the bistable percept paradigm intends to trick the brain and give it that problem, is it a snake, is it a hose pipe, and give it something to think about and work out. And what the test does is it taps into a very old phenomenon that people know about, which is whether something is one image or two. So here on the left you've got a wonky candlestick, but on the right you may have the same candlestick or vase, but also of course those faces in profile. Yeah? You remember this is an oldie but a goodie. So there are two pictures in there. Okay? So your brain has to be able to look and work out there's more than one thing. Now, in terms of the test, you can get that test wrong in a couple of ways. You could look and say, well, I see the vase, but I don't see the faces. And that's bad. However, what you could do, which is worse, is look at the vase and the faces and go, I see the devil. Because your brain is suddenly conjuring up images. I kid you not. So these are some easy ones. What do you reckon? One image or two? Well, we've got vases, we're happy with that. Can we see some faces as well? Yeah, you can see some faces, and some of them there's some laughing, happy, smiley faces looking at each other. and here not so happy, and there pretty plain. How about this one? Just a horse. It's a horse. Yeah, I like horses. It's just a horse. Just a horse? There's a ripple around the room that suggests that some people are seeing more than a horse. How many people have still just got a horse? Yes, there's a smiley face in the clouds as well, isn't there? That's right. You didn't see the smiley face? Oh, okay. Yeah, the smiley. We'll go with the smiley face. How about this one? It's a reindeer. But of course, for those of you who haven't seen it, there's another reindeer hiding here in the trees. But interestingly, when I show this picture to people who've got hallucinations, they give me a different answer. And they say, well, actually, Doc, I can see these people hiding in the trees. See those arms of those shadowy people? And this is a little bit surprising, but here's a video of people doing this task.
That looks like a nasty piece of work there, a figure of something to fear, the eyes and the mouth. And these two look like animals of some sort looking at the horse. A tree, no less. Little children images dangling off there.
So you can see children?
And all round it, in fact.
So this is a study where we're looking at where he's looking, and he's pointing out what he's seeing.
Chin there.
You can see a chin at the bottom, he says. And of course it's just a rose. But he's starting to see faces that aren't there. So this test has been very helpful for us. And what we've done is had a look at this test with some brain scanning techniques. And one of the scanning techniques we've got uses the chemistry of the brain. It uses an MRI scan, like a standard MRI scanner. We look at the chemistry of the brain to look at how much damage there is to the brain cells, the neurons. And we pick a particular area of the brain that we think is involved in those networks that I was talking about. And what we're able to show is that patients with hallucinations have got more nerve cell damage in that part of the brain that's trying to work out those images, and that the damage to those cells correlates, as you can see with that straight line, with how bad you are at the test. So the first time I've got an objective test that I can tell the difference between hallucinators and non-hallucinators, and also correlate the degree or the severity of hallucinations with the chemistry, the damage in the brain itself. And on top of that, what we're able to do is while people are actually in the scanner looking at those pictures, we're able to see which parts of the brain are failing. And interestingly, the part of the brain which you see here in blue is the part of the brain that's involved with conflict resolution. That third network that says, I'm going to sort this problem out for you. And in hallucinators, compared to non-hallucinators, that part of the brain isn't firing up properly. So our next study is going to be looking to see what the effect of dopamine is on that. Because what we know is that patients who hallucinate generally get better if we take down their dopamine tablets. And what I'm hoping is that we'll be able to start getting some insights into what's going on in the brain, and actually what other tablets could we use to change this function in the brain and stop the hallucinations from happening. I'll just skip over that. In terms of what I'd like to see, so in terms of some practical advice, on what I've told you, one of the things that can help with people who are hallucinating is improving the visual information. So if you are getting up in the middle of the night to go to the bathroom and seeing things, actually having a bit more light on the subject. So not having little coffee tables that are low down, they've got 4 legs, they could easily look like a dog, and they can be frightening. Get rid of the coffee table, get rid of the clutter, improve the lighting in that area. And then in terms of the treatments, we're hoping to focus the activity in the brain, and we'll do that with medication. And obviously, if you get hallucinations and you weren't expecting them, make sure that you've not got constipation, or that there's no infection or salt imbalance, no new medications. And also we need to work on improving memory. So for example, one of the things I notice in my patients is that if they go somewhere unfamiliar, that's when they get really bamboozled, confused, and more likely to hallucinate. So if you are going away, take some familiar things with you. your husband or wife is a hallucinator, take some familiar photographs, make them feel as though they're at home, something they can latch onto and focus, so that they don't get too flustered or frustrated. My final slide is, my penultimate slide I should say, is to acknowledge all the people on here that A, have done all the hard work and allowed me to come and stand up and tell you about it. So people like Mac, Shine and Sharon Naismith and Glenda from the Brain Bank and all the clever people who do the processing, the imaging. And importantly, the people who pay. So people like the NHMRC, Parkinson's New South Wales, the ARC, Brain Foundation, Michael J. Fox Foundation. And then my final slide is one of my oldest slides, which basically says this: all of the stuff that I've shown you today involves people like yourselves getting involved in research, because none of the stuff that I've shown you today can be done with these guys. The guinea pigs that I use for all of my research are about your age, about your height, and really it's all about you. Thank you very much for your attention.
Questions, and Ed Hurley will bring the microphone to you.
"59 minutes, by the way, can I just say? 59 minutes.
Sorry, what was your email address again?
Sorry. So pd.clinic@sydney.edu.au. So Parkinson's disease.clinic. So pd.clinic@sydney.edu.au. Just Google me, Google Parkinson's, Simon Lewis. I'm sure you'll find the emails and everything else.
So in Canberra, we could still be involved?
Yeah, I have patients who come to me from Queensland, people who come from Victoria. I've had patients come from New Zealand to come and get involved. So basically our research clinic is a free clinic. Essentially it's there to do research. If people are kind enough to come and see us, we will do everything we can do. We generally ask people to come at least once every couple of years, just so we can track them and monitor them. Some of the other studies are much more involved. So memory training, twice a week, every 7 weeks, is harder for people who live, out of area. And that's true even in Sydney, of course. We've got questions.
In terms of timing and starting or increasing medication or any treatment, is sooner better than later?
Great question. So everyone, I might just rephrase or repeat the question. Just I can hear you perfectly. I think everyone can. So when should we start treatment with Parkinson's disease? The answer is we don't know. And what we do know are these things. Number one, when we look at big studies, people's quality of life improves when they start treatment. So those are big studies, so with a couple of thousand patients. That doesn't mean to say that every single patient's quality of life will improve, and it doesn't mean to say it will improve by a lot. But we know that treatment generally improves quality of life. The flip side of that is you can never have a side effect unless you're taking the tablet. And of course we know that the longer you're on tablets, the more likely you are to get side effects. The treatments that we have, none of them have definitely been shown to stop the disease. And as such, we have no evidence that starting early will slow the progression of the disease. So it really comes down to an individual choice as to when the symptoms, I think, lead the game. And I think when people ask me, when should I start treatment, doctor, I usually throw it back to them and say, when you tell me you need to. But there isn't a right or a wrong answer. Next. Got loads at the back.
I'm just about to go through a process of redoing my will. If I want to donate any of my remains to medical research and Parkinson's research, what would you? Is that a useful thing from your viewpoint? So what should I put in my will?
I thought you were going to ask me if we wanted your money. So the answer to your question is this. Donating your body to medical research generally has always happened through the medical schools. So effectively, when people say, I'm donating my body to medical research, it's generally coordinated through a thing like the Department of Anatomy within a medical school. And in that, what will happen is that people's body will be used usually for cadaveric, that is to say post-mortem dissection, to teach students what the anatomy of the body is. That body is generally never used for any specific research. And what I mean by that is that it's not as though if you have Parkinson's that they will take your brain out and enter it into a program specifically for Parkinson's. On the flip side, the brain donor program that I'm involved with, we only take the brain. And so effectively people ask me, gosh, what are the whys and the wherefores of that? And just to cover it, essentially there are no costs. The idea is that people will generally have no delay in their funeral arrangements, and the question I often or sometimes get asked is, will an open casket still be appropriate? And the answer is yes. The brain is taken usually within 48 hours, and it's then prepared, and half of it is frozen for later use and half of it is fixed for specific research. In actual fact, what tends to happen is that the brain tissue is then released as research people apply asking for tissue. So the difference between donating your brain to medical science versus entering a specific program, and the same is true for people who might be in breast cancer programs or any other programs, is that the general donation is not used for specific research. It's usually used for teaching of medical students.
Hello Simon, it's Gordon Gregory up here in the Naughty Corner.
Hello sir, how are you?
You said that if there was a cure for Parkinson's, you mentioned, just arbitrarily, you said if it cost $15,000.
No. What I said was these guys are offering a cure for $15,000, which is clearly not going to be the case.
No.
So, I mean, effectively what you're seeing is a situation at the moment where online you can go and find somewhere in China that will offer you stem cells for your cure, and they'll generally charge around the $15,000 mark. So the bottom line is they're pitching it at a level where people think, oh, it must be good because I've got to spend money on it, and it's not too much that it just kills them out the game. I'm not suggesting for 1 second that any cure is going to be $15,000. Quite the reverse. What I'm saying is, if you hear someone who's got a cure for $15,000, in the words of the Castle, tell them they're dreaming.
I understand that, and I was making I want to go hypothetical. That is, the notion that if a government could find a cure for Parkinson's, they would buy it. My comment is this: that in fact, it's no criticism of any particular party or government to say that in fact, investing today public money through government in something which is prevented tomorrow tends not to yield the sort of returns to government in a political sense, so that's probably one of the reasons why it's been estimated that we spend only 3% of our total health dollar in Australia on prevention. Because if you invest today in something which is prevented tomorrow, it's very hard to prove the benefit, and therefore it's very hard for a political party or any government to get credit for it. So that's my comment. And my question, completely different. Can you talk about glaucoma and dopamine?
So your comment is absolutely accurate, and I think the problem we have is convincing governments that there is a benefit to saving money at a time when they are focused on not spending money. Because as we all know, you need to invest, speculate to accumulate. In terms of the glaucoma question, the essence of glaucoma at the moment with Parkinson's is with regard to the treatment and making glaucoma worse. And so the advice is actually not around dopaminergic drugs, but it's around cholinergic drugs. So medications like Artane or Benzhexol, and those drugs need to be used carefully in patients, especially with closed-angle glaucoma. And I think the obvious thing to bear in mind is if you have any concerns about your medications with glaucoma or any other conditions, that you should discuss them with your specialist.
Doctor, with movement problems, have you had any experience or knowledge of Botox injections to assist with movement problems?
Yes, it's a negative experience. So people may be familiar with Botox. Obviously, there's the crow's feet cosmetic Botox to try and get rid of your wrinkles. In neurology, we tend to use Botox for people who have developed spasm in the muscle, or what we call dystonia. So patients who might have conditions like torticollis, where their neck is twisted, or other dystonias such as a face that keeps twitching. In Parkinson's disease, we generally don't see much use for that because the dystonia isn't a major feature, or it's very intermittent, and when we try to treat it, you actually weaken the muscles so much that they become less useful than having the pain of the dystonia. Specifically, people thought that it might be useful to treat freezing of gait patients with Botox, and the study was negative. In actual fact, it made their walking worse. The other use for Botox we see in Parkinson's disease, which has mixed results, is for people with Parkinson's who have too much saliva. So they're drooling and they can't clear their saliva. And injecting Botox into the salivary glands paralyzes those for 3 months, and patients will stop producing saliva. The problem with that is the patients often then flip and start complaining that they've got a dry mouth, and that's worse than having the drool. And there are also some other things to consider with Botox for the salivary glands, and it can sometimes affect your swallowing so badly that you might even need a feeding tube for a couple of months until the function restores. So it's something that I have done in patients, but you have to be very careful.
Professor, I'd like to ask a broad question about hard physical exercise.
Yep.
What particular role do you...
So exercise in Parkinson's is a very hot topic, and the answer is yes. So all of the studies that have been done looking at exercise in Parkinson's would encourage you to do it. They all seem to improve your general quality of life, and improve mobility. It's not so clear that they reduce falls. So that was one of the things that people were hoping, is that they would reduce. They can increase falls, in fact. So and it's probably true to say that when you need to be doing exercise is really early in your disease. In fact, before you need to. And what I mean by that is the same with brain training, exercising your brain, same with physical exercise. The benefits are actually much greater when your function is quite good, rather than when you're somebody who's already started to fall over, because then the risk of falling begins greater. And it's interesting because this is one of the arguments that I put when I talk to people about making a diagnosis of Parkinson's disease before the disease has started. So I talked to you about those patients with punching in their sleep, and I said, look, we actually now have a clinic getting those patients in for me to look at to say whether A, they have Parkinson's that just hasn't been picked up, or B, I think they're about to get Parkinson's. And people have challenged me and said, but doctor, why are you telling them they've got the risk of getting Parkinson's if you've got no treatment or any cure? And the answer goes back to the very crux of what you're asking, and I say to them, well, actually, A, knowledge is power. So just be able to plan things like, well, when's my retirement going to be? Do I need to live in a bungalow? And also being on the front foot and saying, well, bloody hell, I'm going to start doing some exercise, I'm going to take some time off in my week to do that, I'm going to start exercising my brain, is one of the reasons that I would strongly hold that we should be looking to make a if you like, a pre-physical diagnosis of Parkinson's disease. So the straight answer to your question, all exercise is good. When they've looked at the studies they've done, they have never done head-to-heads of one type of exercise versus another. So strengthening exercise, for example, building up your quads and your core body strength, versus aerobic exercise, which is being able to get your heart racing. Both of them seem to be good. They've never really gone head to head to say is one better than the other. My suspicion is you should try and do a little bit of all of them, because I think that's what we would expect, a common sense approach to help with your Parkinson's.
Thank you very much.
My pleasure.
And you mentioned those two new
drugs, the neuroprotection type of drugs, the Resagiline and...
Yeah, so Resagiline has got some mixed controversial data that it might slow the disease. Rotigotine, which is the patch, has no such data. It's an effective treatment for early and late Parkinson's. It's a useful additive treatment, but it hasn't got the same evidence for slowing the disease.
So, say someone like my husband on 1500 milligrams of Cinemet a day.
Yep.
What would then happen?
Just a little bit closer to the mouth, I think.
Oh yeah, I got. What would then happen? Would you?
So if you added one of those new drugs to somebody who's on quite a lot of levodopa, so 1500 milligrams of levodopa is quite a lot. So 1500 milligrams of Cinemet would be what? You put it on 2 hours or something.
250.
Yeah. So the bottom line is adding anything that boosts dopamine in the system is likely to trigger off those side effects that you see in those patients. And what I mentioned in my talk was, if you have patients with advanced disease, with hallucinations, usually you would reduce their dopamine treatment to try and help. And I think the answer for adding those medications is whether you think you're going to improve the physical control of the disease, outweighing the risks of making some things like confusion, hallucinations, lowering the blood pressure worse. And again, specifically in consultation with your specialist, you'll be able to answer that. The fact is,
dopamine products.
So Resagiline is a drug that works in the brain to slow the breakdown of the brain's dopamine. So just as you have enzymes in your stomach that will break down the food that you eat, we have enzymes in our brain that break down the dopamine. And so, just like a thermostat, you wouldn't want to just keep getting hotter or getting more levels of dopamine. Your brain will clear it. What Resagiline does is it goes in and it slows that breakdown and elevates your own dopamine, which is why it has probably less side effects than most. Rotigotine is a dopamine agonist from the same class as pramipexole or Cifrol. And that drug goes into the brain and pretends to be dopamine. So it stimulates the receptors that dopamine would. So they're both dopaminergic, but neither of them are dopamine.
So, what I thought you were saying before then was that you could have less of the actual dopamine if you were to have these, and therefore hopefully less of the side effects.
And that's exactly what we do in clinical practice. So if we have a patient who's on high doses of dopamine, and we'd like to maybe try and smooth things out, either with, say, a patch that's there 24 hours or a tablet that's once a day, like Resagiline, you actually might think, well, we could probably reduce the dopamine, levodopa, Cinemet, Parkinson, Stalevo, and actually, you know, if you like, overall keep things about the same or a little bit better. That is absolutely the strategy we use in clinical practice.
So, to me, my husband's like to go to duodopa, but it seems as though it would be a good idea to try this as a strategy first.
Well, as I say, it's never in these situations will I discuss an individual case. And what I will say to you is this: if patients have got a very high load of dopamine that they need to take, and they're getting symptoms, usually with fluctuations where they're switching off or getting dyskinesia, then fiddling around with oral preparations or patches generally is not in the same league as the advanced therapies such as deep brain stimulation, duodopa and apomorphine. So it seems, your individual case, but certainly on a group level, that those patients will actually probably be better off having the advanced therapy instead of tickling around with tablets all the time.
Thank you. In your discussion of hallucinations, you talked only about visual hallucinations.
I did.
What about the other senses?
So the reason I talked mainly about visual hallucinations is because they far and away dominate in Parkinson's, but you're absolutely right that you do get other hallucinations, so auditory hallucinations, tactile, feel like you're being touched. But they're less common and they're usually in more advanced patients. The fact of the matter is, we've just submitted a paper about this called the common neural mechanism, and I actually think the same networks are probably responsible for the auditory hallucinations, and certainly in other conditions as well, like schizophrenia. So in schizophrenia, what we know is that the nerve cells in schizophrenia seem to be damaged or different, if you like, in the area of the brain that deals with auditory processing, which, given the schizophrenics tend to have mainly auditory problems, sort of fits with the model. And if you think about the model as rubbish in, rubbish out, so poor visual perception or auditory change, then actually your brain is trying to make sense of what's been put into it. So Bertrand Russell, who's a Welsh philosopher from the last century, said, hallucinations are not an error. What you do with them is the error. So in actual fact, your brain is making sense of the information you've given it. And I think the truth is that the auditory hallucinations we see in Parkinson's and the tactile hallucinations are probably working through the same networks, but obviously are less florid because the damage in those networks is a bit later on. Okay.
Thanks very much for the presentation, Professor. You mentioned very early in the piece Razagiline, and you mentioned Azilect in the same sentence. Is that the same?
It's the same drug. So Razagiline is the generic, the name, the scientific name for it. It's the name that I knew it by when... The reason I'm on the advisory board is because I was actually in Cambridge, and Cambridge was the biggest centre that coordinated in the UK one of the studies. So I knew Razagiline as Razagiline for about 4 years, and then the drug got released, and I had to go on the radio, and that morning they told me the drug's name is Azilect. We've chosen this name. It's the company name for it. It's a bit... it's the same with pramipexole and Cifrol. Cifrol is the trade name, pramipexole is the generic or the scientific name.
The other quick question is, in terms of medication and the disease, what is the overall effect on vision?
On vision, did you say?
Yes, on your eyes.
Yeah. So the disease itself affects vision. So we know that, and I alluded to this, we know that the sleep problems are an early feature that can happen before the physical disease. I mentioned mood problems before the physical disease, sense of smell and losing your sense of smell before the disease, and vision changes. And vision changes in a couple of specific ways. One, you lose contrast sensitivity, that is black versus white and all the shades of grey, and colour discrimination. So yellow versus light yellow versus orange versus green become impaired. And we know that there are dopaminergic cells at the back of the eyeball in the retina, and these are dying in Parkinson's. What we haven't got such good data on, because we always focus on the physical aspect, is how much change the tablets or the medications are making to vision itself. And of course, vision is more than just your eyeballs. If you've ever had a migraine and you've got those zigzaggy lines, and you hear about patients talking about zigzaggy lines, ask those patients, close your eyes, and they'll tell you that they still see the zigzag lines. The reason they do that is because the pictures are coming from the brain, making sense of the information it's got. And the same is going to be true in Parkinson's. So it's not only the visual acuity, if you like, seeing things sharply in colour and contrast, but also making sense of them. And we see this with Parkinson's with regard to what we call visuospatial. So for example, when people are driving, they become worse drivers with Parkinson's. Much worse at night when the lighting is lower and the judging distances becomes harder. So we don't have a good feel for the tablets, but we do realise that it's a very key part of the disease. Is that okay?
I have been taking Azilect for 5 years now. I don't know whether that's stopped Parkinson's progressing or I don't know what to do with it.
Okay, well, as I said to you before, the best thing is always to speak to your own specialist because they know your case. If I step one step back, I'm told by patients a lot of the time, Doc, I really don't know if these tablets are doing any... How many of you have said that to your specialist or to your friend? Doc, I don't really know if these tablets are doing anything. And the fact of the matter is you go, oh, well, I miss a dose here and there, I never notice. Back in the day, sort of in the 1970s and 80s, when we started realising that dopamine wasn't necessarily the best treatment, also it wasn't as good as we hoped it would be, there was a vogue for bringing patients in on what used to be called drug holiday. So we would bring them into hospital and we would stop all their tablets. And I can just about remember this when I was a junior doctor, and we had a couple of these patients come in. And what would happen is you'd stop their tablets and nothing would happen for days and weeks sometimes. because the dopamine that you're taking is not only just a replacement of the dopamine, it is changing the receptors in your brain. So often, the effects of your tablets aren't just as simple as 1 day later, 2 days later, it can be 4 days later. Just like when your doctor says to you, gosh, yeah, you need to keep taking the pills a bit longer, you haven't had the benefit yet. The same is true in reverse. And often it's worth just considering that before you start stopping your tablets, and also worth remembering, well, if your tablets aren't causing any side effects, it may well be that you're better off taking them than stopping them. Okay? There's one over here. Hello.
Hi. I'm a physio. I have a question about microbrachia.
No, more importantly, I've got a terrible strain. I was playing hockey last night. I really need some help. Mr. Gregory, I've pulled a muscle here. You know what it's like in hockey, right? It's terrible. Sorry, go ahead.
Interesting to me if those effects will have an effect on your Parkinson's, whether you have those pre-existing sport things.
Absolutely.
But my question is about writing. So,
yep.
Are you able to give a quick explanation as
yep.
to why?
Sure can. Absolutely can. So, the core features of Parkinson's disease are tremor, which is usually resting, and it's called a pill-rolling tremor. And you know why it's called a pill-rolling tremor? Because in the old days, before the manufacturers and the factories used to make pills, people who would actually do this, the apothecaries, would actually just roll them by hand. If you've ever seen the tremor, it looks like that, and that's how they describe it. So pill-rolling tremor. Stiffness, so what we talk about is cogwheel rigidity, when you feel the toe and it sort of does this jerky thing. Slowness, or what we call bradykinesia, and late in the disease, postural instability, so you lose your balance and you sort of lose your writing reflexes. So as soon as you topple, you don't just correct yourself. Now in those, bradykinesia effectively means that you make smaller and smaller movements, and this is most commonly seen when you make repetitive movements. So when you go to the doctor, they will probably ask you to do things like walking, where you have to make a repetitive movement, your arms swinging and your legs swinging. And they'll ask you to do this thing. Have you been asked to do this thing? Yeah, oh, bloody hell, you asked me to do that crocodile thing again, yeah. And what's interesting is the doctor is looking to see not only how far you go and how fast you go, but whether it comes down in amplitude and stops. So it will sort of break in amplitude, and sometimes people end up just doing this business. And handwriting is, of course, another exercise where amplitude is important, and keeping the amplitude. So as you're writing, what you'll hear from patients usually is not, my handwriting's terribly small, doctor. What they'll usually do is this. So I don't know what that sign should be called, but they usually do this. My handwriting, and by the time they've done this, you know what they mean. As they're writing across the page, and it doesn't matter what language is in, I haven't got the video just to hand to show you, I've got a nice Chinese writing video that does exactly that. The amplitude comes down because they cannot maintain that amplitude, or what we call the motor set, and people basically become smaller and smaller and smaller. Interestingly, just like things like freezing the gait and queuing, what people try and do then is do a goal-directed movement, because writing in running writing or cursive writing is automatic. How many people in the room with Parkinson's do block capital writing now? Yeah. And you swap to doing block capital writing because it makes an effort. You don't generally do it normally, and it makes it a bit clearer, and the letters all should be big. So it actually is you trying to overcome that with a goal-directed action. So that's what I think about micrography. Small handwriting as it's known.
So I've got two things. One is, it seems to me that a memory training app put on iTunes could make you an absolute fortune if only you sold it in Australia for $3, which is kind of typical price. You could make, I've just iTuned it and there aren't any.
Yeah, now listen, I'll stop you just there. So in fairness to the people who do this, so the way that our memory training program works is the neuropsychologists can spot the deficits and work with the patients pretty much one-on-one. People in the UK, they did a big TV, the BBC put this on, they did this online training program and showed it didn't work. In fact, one of my old supervisors, Adrian Owen, was involved and basically kind of poo-pooed the whole thing. And it's true to say that just going online and practicing, because everyone asks me this question, go on Simon, it's rural Australia, how are you going to do it? And the answer is we're going to do it properly and find out what works. So I've got people up the pipeline who I think will do that. When I've got an idea that it'll definitely work and how. In the interim, there is a website, pens at the ready, called Lumosity, Lumosity. I get no money from Lumosity, I hasten to add, but having spoken to Sharon Naismith, this is the one website that she says, look, if anything you're going to do, and I think you do have